It's a hot August night in eastern South Dakota, a great night at the county fair. The mosquito that transmits West Nile virus comes out to feed on warm July and August nights like this one, but no one is swatting mosquitoes. In South Dakota, public health officials, scientists, and communities joined forces to prevent West Nile disease, and now they're getting some help from space.
West Nile virus is actually a bird virus that gets accidentally transmitted into humans and horses and other mammals. In this area, Culex tarsalis is the primary vector for West Nile virus.
The conditions in parts of South Dakota seem to be particularly good for Culex tarsalis and for the mosquito to come into contact with people.
South Dakota has the highest incidence of West Nile of any state in the country. It's a bird disease, but it can cause acute illness in people. It can put people in the hospital. It's killed 35 people in South Dakota already. We need good predictors of when the conditions might be right for an outbreak of West Nile disease.
Public health officials estimate the risk of humans becoming infected by trapping mosquitoes and testing them for West Nile virus. But it's impossible to get enough data to cover such a large, sparsely populated state. The South Dakota Mosquito Information System is using environmental data from space to close those gaps.
We came up with some new ideas for how to develop an improved system for forecasting West Nile virus, leveraging information and satellite imagery. The major goal of our project is to develop a dynamic risk mapping approach for West Nile virus and to produce forecasts and risk assessments that are useful to public health officials and can actually be applied to do a better job of disease prevention and mosquito controls.
The South Dakota Department of Health provides important data on the location of infected mosquitoes and on human cases to Dr. Wimberly and Dr. Hildreth.
The mosquito data allows us to get a very accurate estimate of disease risk, and the environmental data allows us to extend that over space and through time.
The approach that we're using for this project is really to take the mosquito data, the virus data that we have from the various years, and look at correlations between the years that have a lot of transmission of West Nile versus low transmission, correlating that to environmental data that's coming from the satellite imaging.
We've used a variety of MODIS products, and they've been particularly valuable because they provide consistent long-term records of these environmental observations that we can use to study disease over multiple years. The Landsat satellites have also proved to be very useful, particularly for trying to do more detailed, finer scale risk mapping.
We're looking for patterns, predictive patterns, much like the weather forecasters are doing.
Temperature has really proved to be the most important variable for West Nile virus in our state. People tend to associate mosquitoes with rainfall and water for breeding sites. But you also have to remember that these mosquitoes are tiny, cold-blooded organisms. And as a result, all of the processes associated with mosquitoes are all strongly influenced by temperature. Even the rate of development of the virus inside the mosquito is strongly temperature sensitive, so that generally when it's warmer, a mosquito can transmit the virus more rapidly than when it's cooler.
The combination of the disease data, the environmental data, the climatological data is exactly what we need. West Nile is a very complex disease.
What we're working on right now is putting out weekly risk assessment reports, and we combine that with a risk map based on temperature.
We're trying then to help people take precautions during those high transmission years, during those peak transmission time periods.
The information that we're getting from the project are maps of risk factors associated with things that we at the health department really can't track or figure out. Things that have to do with climate, lay of the land, precipitation, what's growing, and they're able to pinpoint potential hot spots across the state of South Dakota. I think this will be absolutely an essential tool in controlling West Nile here in South Dakota.
Our top priority of our program and our mission of our program is the protection of the public health of the citizens of Aberdeen. We run a mosquito control program, and it's an integrated pest management program. I told our community leaders a number of weeks ago when those threat assessments came in that we were shifting our efforts now away from nuisance mosquitoes onto the culex and the virus mosquitoes. So we're really excited about that project. We think it's going to be a tremendous help to us.
This West Nile NASA project is the first real project where I've been involved, where we've seen practical use using our state health department disease data, correlating with the NASA environmental and climatological data to really make some good predictors of a disease that's really hurting and killing people in this state.